In this video, we are going to discuss multiplication of matrices. The product of AB can be found if the number of columns of matrix A is equal to the number of rows of matrix B. If the order of matrix A is m by n and B is n by p, then the order of AB is m by p is given the definition. Just you remember that I am considering two matrices. One is A and another one is B. So always number of columns of the first matrix must be equal to number of rows of the second matrix. Suppose I am taking this is m by n, this is p by q. Always you have to remember that if AB exists, then n must be equal to p. These two must be equal. These two terms, n must be equal to p. That's one. Then the resultant matrix AB, that is the product. The order of AB will be m by q. This is the order of the resultant matrix. For example, suppose there is a matrix C of order m by 3 and D is of order p by 4. Then if CD exists, then the resultant CD exists, then P must be equal to 3. And the order of the resultant matrix will be m by 4. Like that, if DC exists, now D is the first matrix, C is the second matrix. In that case, D is of order P by 4 and C is of order m by 3. Then these two must be equal. Then the required condition is m must be equal to 4. And the resultant matrix will have the order p by 3. That is the outer values. These two values, p by 3. Okay, children. Suppose I am considering two matrices. A is equal to 2, 3, 4, minus 1, 0, 2. This is of order 2 by 3. And B is another matrix. I am taking, this is 5, 7, 1. This is of order 3 by 1. Okay, children. If A is equal to this and B is equal to this, then find AB and BA if they exist. Okay, children. Say first I have to discuss for AB. While going for AB, A is of order 2 by 3, B is of order 3 by 1. Here number of columns of A is equal to number of rows of B. Okay, children, which implies AB exists and B is of order 2 by 1. Now we can go for AB. Now I'll explain how to multiply two matrices. Please listen carefully. 2, 3, 4, minus 1, 0, 2. Then B matrix 5, 7, 1. Here only one column is there. Whatever may be, just I will explain the method, what to do with that. So you have to consider the first row. Okay, children, you consider the first row. Then first column. This is equal to, see, you have to take the product of these elements, that is row by column, and then you have to add that. Listen here, 2 into 5, 2 into 5 plus 3 into 7 plus 4 into 1. So I multiplied first row by first column. First row and first column we multiplied. If we have one more column, you have to multiply the second column by the first row. Here only one column is there, so we are going to stop here. Now you have to move on to the second row. Second row elements are minus 1, 0, 2. You have to multiply the first column elements, that is minus 1 into 5 plus 0 into 7 plus 2 into 1. Therefore, this is equal to, you just do the calculation, 2 5s are 10 plus 3 7s are 21. Then 4 into 1 is 4. Next is minus 5, 0, 2, which is equal to 21 plus 10 is 31 plus 4, 35. Minus 5 plus 2, that is minus 3. So this is the required AB matrix, which is of order 2 by 1. Now you have to go for BA. Number of columns of B is not equal to number of rows of A, which implies BA does not exist. Clear, children? Here AB exists, but BA does not exist. Not only that, some cases AB and BA will exist, but it need not be equal. So we are going to discuss some properties based on the product, that is matrix multiplication. Please go through this. We have to understand how we have to take the product. Next is properties. First property, A property, A is matrix multiplication is not commutative in general. So always you have to remember that AB is not equal to BA if both exist. Okay, children? If A is of order m by n and B is of order n by p, then AB is defined but BA is not defined. Even if AB and BA are both defined, it is not necessary that they are equal in general. In general, AB is not equal to BA. Okay, children? B property. Matrix multiplication is distributive over matrix addition. That is A into B plus C equal to AB plus AC. Second solution in that A plus B into C is equal to AC plus BC. Third one, matrix multiplication is always associative. Associative property is true always. So you must know that. Matrix multiplication is always associative, but it's not commutative. Okay, children? It's always associative, but it's not commutative. So you must know AB is not equal to BA, but AB into C is equal to A into BC always. Next, D. Multiplication of a matrix by a unit matrix. AI, that is A into I matrix, is equal to I into A matrix equal to A matrix. This is known as identity matrix. I is known as identity matrix. Okay, children. So these are the properties you have to remember. AI is equal to I into A is equal to A. This is known as identity property. Previous one is associative property, that is AB into C is equal to A into BC. Okay, children, these are the things you have to remember. Very important one is matrix multiplication is associative, but it's not commutative always. If x and y are two real numbers such that xy is equal to 0, then either x equal to 0 or y is equal to 0. But this condition may not be true with respect to two matrices. Here they given AB is equal to 0, AB is equal to 0 does not necessarily imply that A is equal to 0 or B is equal to 0 or both A comma B is equal to 0. Example here, just I want to give one example. Let A is equal to one matrix I am taking minus 1, 1, 1, minus 1, and B is equal to 1, 1, 1, 1. Here A is of order 2 by 2 and B is also of order 2 by 2. We can find AB and BA. First we have to find AB, that is minus 1, 1, 1, minus 1. This is A matrix into B matrix, that is 1, 1, 1, 1. Already I explained, we have to take row by column. Okay, children? This is equal to first row by first column. Minus 1 into 1, that is minus 1. Then 1 into 1, that is plus 1. Next, with the same row, second column you have to take. You have to take the second column. This one. This column you have to take. First row into second column. Minus 1 into 1. You are getting minus 1. Then 1 into 1, that is plus 1. Clear, children? So you must know this. Now we can move on to second row. Second row into first column. That is 1 into 1 is 1. Minus 1 into 1 is minus 1. Now second row into second column. So that is 1 into 1 is 1. Minus 1 into 1 is minus 1. Therefore, this is equal to, we are getting 0, 0, 0, 0. Clear, children? So here, A is not equal to 0 and B is not equal to 0, but AB is equal to 0. Here, A is not equal to 0 and B is not equal to 0. These two are non-zero matrix. But AB is a zero matrix. This is an example for the previous note. If A and B are any two non-zero matrices, then AB the whole square not equal to A square plus 2AB plus B square. So normally we used to use the formula for the real number system. We used to use A plus B the whole square is equal to A square plus 2AB plus B square. But the same result is not applicable for matrix expansion. Okay, children? So that only it's given if A plus B the whole square is not equal to A square plus 2AB plus B square. But if AB is equal to BA, in some cases which will be true, then we can say that A plus B the whole square is equal to A square plus 2AB plus B square. In general, A plus B the whole square is not equal to A square plus 2AB plus B square. Okay, children? Generally, it's not equal. But if A and B, AB is equal to BA, then the result is true. Exercise 3.18. First problem. Find the order of the product matrix AB if it exists. Okay, children? See here. Here they given 5 subdivisions. Order of A and order of B are given. One by one we can discuss. First one. A is of order 3 by 3. B is of order 3 by 3. Now these two are equal. That is, number of columns of A is equal to number of rows of B, which implies AB is of order 3 by 3. That is the outer. Okay, this is the resultant matrix order. Second one, A is of order 4 by 3 and B is of order 3 by 2. So the resultant will be 4 by 2. That is, AB is of order 4 by 2. Now the third one, A is of order 4 by 2 and B is of order 2 by 2, which implies we can write the AB is of order 4 by 2. Here, children. Now the fourth subdivision, A is of order 4 by 5 and B is of order 5 by 1. Here 5, 5, it's equal. Therefore, we are getting AB is of order 4 by 1. Next is fifth subdivision. A is of order 1 by 1. B is of order 1 by 3. Here 1, 1, both are equal, which implies AB is of order outside 1, that is 1 by 3. This is the required order of AB. Second one, if A is of order P by Q and B is of order Q by R, what is the order of AB and BA? Given order of A is P by Q and order of B is equal to Q by R. Here, see here, this is Q, here also Q. Therefore, it's very clear that AB exists with order outside things, outside values, that is P by R. P by R is the order of AB. But now we have to go for BA. B is of order Q by R and A is of order P by Q. Here they didn't give the condition for R and P, so it's not equal, which implies BA does not exist. Okay, children? Third one, A has A rows and A plus 3 columns. So given order of A is equal to A by A plus 3 and order of B rows, so B by 17 minus B, and if both product AB and BA exists, find A comma B. If AB exists, so you know that number of columns of A, that is A plus 3, equal to number of rows of B, that is B, which implies A minus B is equal to 3. If BA exists, then number of columns of B, that is 17 minus B, equal to number of rows of A, that is A, which implies A plus B equal to 17. Now you can add these two equations. You are getting 2A is equal to 20, which implies A is equal to 10. I am assuming this is first equation and this is second equation. Okay, children? Which means this is 1 plus 2 implies. Right, so put A is equal to 10 N2, second equation. Therefore, second equation implies 10 plus B equal to 17, which implies B is equal to 17. So the required values are A is equal to 10 and B is equal to 17. Problem number 4. If A is equal to 2543, B is equal to 1 minus 325. Find AB, BA and verify AB is equal to BA. Given A is equal to 2543 and B is equal to 1 minus 325. Now we have to calculate AB. AB is equal to A matrix first, 2543, B matrix 1 minus 325. This is equal to row by column. So 2 into 1, it's 2. 5 into 2, it's 10. Next, first row into second column. 2 into minus 3, that is minus 6. 5 5s are 25. Next row, second row by first column. 4 into 1 is 4, plus 3 into 2 is 6. Second row into second column. 4 into minus 3, minus 12. Then 3 into 5 is 15, which is equal to 12. 25 minus 6 is 19. 4 plus 6, 10. 15 minus 12, 3. Now you calculate DA. Now I am writing B matrix 1, minus 3, 2, 5. And A matrix is 2, 5, 4, 3, equal to row by column. That is 1 into 2 is 2, minus 3 into 4, that is minus 12. 1 into 5 is 5, minus 3 3s are 9. 2 2s are 4, 5 into 4 is 20. 2 5s are 10, plus 5 3s are 15, which is equal to 2 minus 12, that is minus 10. 5 minus 9, minus 4. 4 plus 20, that is 24. 10 plus 15 is 25. Let it be 1, it's 2. Therefore, from 1 and 2, AB is not equal to BA. Rest of the problems we'll see in the next video. All the best. You just practice the example sums.